Hello. Hi. Welcome back. Let's lead code. Yay. Okay. So let's practice again today. Continuing from Leetcode 75. Let's see if we can try to solve like 2 maybe or 3. So let's see. I kind of want to just pick a random question right here that I haven't done. So let's see. Backtracking. Why not? So, letter combinations of a phone number. Given a string containing digits from 2 to 9 inclusive, return all possible letter combinations that the number could represent. Return an answer in any order. A mapping of digits to letters, just like on the telephone buttons, is given below. Note that 1 does not map to any letters. So like this. The old school way. So A, B, C is within 2, 3, D, F. Okay. So return all possible letter combinations that the number could represent. So 2, 9, what are the possible combinations? It's A, D, A, E, A, F, right? What? 2, 3, oh. And B, D, whatever it is. If it's nothing, then it's nothing. If it's 2, then A, B, C. Okay. And this is 2 digits. Imagine if we have like 6 digits. That could get pretty messy and pretty heavy. So that's one thing to think about. Looking at this question, brute force way is just that you go through each one. I need to test the case of 3 letters. So if we have digits as 1, this 2, 3, 4. What the result is going to be 2, 3, 4. First is going to be A, D, G, right? D, G. And then it's going to go A, D, H. And then it's going to go A, D, I. So you could see like it's already, what is this, 3 times 3? So 9? Is that it? No, I think it's more than that. Let's see. And then A, E, I, A, E, G, and then A, E, I. How many possible solution is that? I don't know. Feels like it's going to be 3 times 3 is 9. But I feel like it's going to be 81 times 3. No, wait, right? No. Okay, anyway. So it's a lot. Even brute force saying this is going to be insane if we have 3 digits. So what can we do? Oh, I forgot. Let's set up a timer here just to see. Just to see how long it's taking us to give up. Oh my god, backtracking. What is backtracking? So I heard about the term backtracking, but it was with the concept of within the concept of graphs. Backtracking. Let me try to think. What is backtracking? Jeepers. Okay, so backtracking. So you're avoiding the situation if deemed to be not an answer. Have no idea here at all. What is backtracking? Well, let's start with what we know. So if digits goes to empty strings, we just return an empty array. So if we want to brute force this, right? Let's just use example as the big. We need result array that we can push to, and then okay, for I equals to 0, less than digits, that one, plus, so we're in digits versus 2. What do we do here? So we're going to take all the A's, AD, AE, AF, and then BD, BE, BF, and then CD, CE, CF. So we're looking in each one of them of the first letter. Then, okay, we need something to hold the information of what is 2, what is 3, what is 4, right? So we need a dictionary. So that dictionary equals to, we're going to say what are we gonna say? 2 equals to ABC, like this. Honestly, I don't know. Hold on. So yeah, let's keep going first. Now the W, X, Y, Z. 0 is nothing else. So this is only asking what letter combination type. So 1 is not star and pound. So we need to think about that too. If we hit 1 star pound and 0, we don't get anything. So first we have a dictionary of all the letters from the numbers. Going through here, digits.length. So we try to find digits I. This right now is at 2. So if we go dictionary of the digits, we'll get ABC. So if I say current right here, we do that. So do we want to use while loop? Yeah, same thing. So for this is where the computation is getting heavier. You can really see we're using nested loop right here. For let j equals to 0, j less than, this is going to be current outline, j plus plus. Then now that we're here, we're looping A. It's going to be looping A to D, A to D, A to E, A to F. Wow. We're using 2 nested loops in this thing. Are you kidding me? So h equals to 0, h less than current. No. Wow, I'm confused, bro. I actually have no idea. Okay, hold on. Oh my goodness. That is actually crazy. What is backtracking? I don't know. Even if I don't use backtracking, how do I solve this? Do we want to take a look at solution? because I have no idea right now. Okay, let's see. This guy has a
All right.
video.
Next problem is the letter combinations of a phone number. As you can see on the screen, and we are still evaluating the subsets pattern. Here's a problem statement. So we have a string containing digits from 2 to 9 inclusive, and we want to return all possible letter combinations that the number would represent. All possible letter combinations that the number would represent. Okay? Return the answer in any order. The illustration below shows the mapping of digits to smartphone. You can see a 2L and so on. Numbers, letters, this is what
Yeah,
you
we
get.
know that.
For example, right, in a number, if someone gave you that number 9, so 729 725, right? Instead of saying 729 725, you just say PayPal, right? And then you would get the number of call, and it'll connect you to PayPal. That's what a lot of people do. So that's what this is about. It's like getting all the different combinations from any given digit, like the different letter combinations you can get from it. And this is a Leetcode medium, so buckle up. For the solution, it's worth noting and even maybe mentioning in an interview how
This problem lends itself naturally to the subsets pattern. To solve this problem, you can use backtracking algorithm as a solution template. Okay.
based on the constraints, we have a small band, right, between 0 and 4 to consider for the number of digits, right? So that can give you a clue that, oh, this can be a brute force type of solution. Yeah. Now, Educative has some nice and decent write-up here, but I'm going to try and summarize it. And the gist of it is we're going to create a function called letter combinations. And I think I can show that in the code actually. So we have letter combinations here. And it does a number of things. To get this out of the way. It does a number of things. It takes in the digits that we're considering, and which takes in a string, digits, as input, and returns a list of all possible combinations. And you can see it returns combinations down here. The function will be the backtrack function that has all of these goodies. And we're going to do a bunch of things. So it's a full combination, so we push that into combinations like so and return. And that's where we backtrack, step back. Letters corresponding to percent. Yes, that's the digits mapping at the current price. Matic 1, 2. So 3 to the power 2 in the worst case.
So we have a backtrack function. First is the index. What is the path? What is digits, letters, combinations, digits mapping. Combinations is the result array. I see. It's just passing those in. What is numbers? The digits is digits. The input. So we have the index. What's the index? Now we need to specify it's from 0, I guess. So I'll specify that path. If path.length equals to digit.length. So let's try to make sense of this. And do we say this? How do we set the size on this thing? Right here. So we have backtrack function. Backtrack. What am I going to do here? Digits, digit mapping combination, backtrack. If path that line, so we have an array of first is starting from the index, and we have This is what we call path. So, and then the rest is given dot dot dot. And then if path dot length and digits dot length, path and digits, that means we got the length of the possible letters, right? We post the combinations. That's pretty easy. Path that join everything. Okay. Let the possible letters equals to letters, which is the digits mapping of digits index. Yeah. From 0. If possible letters, this is where we call this recursively. I honestly have no idea how this works. Zero idea. Zero idea. We're calling the backtrack function recursively. Let's go through this part right here. Possible letters, letter, digits of index. Let's use the 2, 3, right? So digits of index, digits. What's digits? Digits of index. This is index is still 0 right now. We got 2 letters of 2, right? Possible letters, and then we get ABC. So we have first A, B, C. We're here index at 0. And then if possible letters, for looping through possible letters, ABC, letter first is A. So we're here at A. Path dot push the letter. This is on first backtrack, right? The path is here. So first path dot push letter. We're pushing that letter A. And then while we're here at A, we do backtrack again with the index. Index is still 0, but here we're saying we're calling it 0 plus 1. And then path, we pass in the path. Right now the one that we're passing in is A into the second backtrack. Right, so while we're backtracking this, so now index is at 1, and then possible letters is digits index of 1, which is 3 now, and letters of the 3 is going to be D, E, F. So this is going to be D, E, and F. And then if the possible letters if possible letters, I don't remember. We're not like taking it out. I don't get this though. Yeah, sorry, was distracted. So now I'm at DF, right? I still don't get this though. If possible letters, how is possible letters just going to go away? It's not going away. Anyway, so now we're pushing the path instead of just A. This is gonna be A, D, right? And this is where we get the AD, AE, and AF. This is where we get it. And then when so how does it go out of that? Once I'm done with the backtrack path dot pop. Oh, doing this. We pop that and then we get B. And then we pop that and we get C. And then we pop that and we go out. Okay. I still don't get it. Because if it's index at 1 plus 1 equals to 2, you don't have it. And like, what is the limit on the backtrack? We're calling it recursively until when? So when we, after we push, we return. After this being pushed, we go up here again. Going to B. I see that. Okay. Does that make sense though? Let's try to write it out. So I have an idea now, right? So we're using backtrack to recursively adding possible letters, right? First we need to have a dictionary dictionary will consist of the numbers, which is like 2, and it's going to be an array. I wish I don't want, I don't want to like spend too much time on just writing that thing, so I'm going to do this, and then this, and then A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, S, A, U, V, W, X, Y, and Z. So we have dictionary, and then we need a result array that we can push in, and then letter combinations. We need the backtracking function. So the backtracking function is going to take this index path. We will have the digits. We will have the dictionary, and we have, what's the last one? Index, path, digits, dictionary. I don't remember now. What do I need? Index, path, digits, dictionary, and result. Like that. Thought I could just use result up here. I don't remember the last one. Okay, do what I remember first. And know if digits goes to empty string, just return empty array. Then we're calling this backtrack on index 0 with empty path, digits, and dictionary, and something else I don't remember. And first things first, if path.length equals to digits.length, we want to push our current path and then return. This is the backtracking. And then possible letters equals to dictionary of the index. So if possible letters, again, like I know this because I've seen the code, not like I came up with it, you know. So now if possible letters, I need to loop through where for let I equals 0, less than not length, plus plus. So I'm in the for loop now. We have possible letters. Now we're here at ABC. That's the first one. I want to push the path of possible letters. Current one is the I, which is A. Right. After we pushed into path, after we push into path, we run backtracking on the index plus 1. We pass in the current path and then current digits and the dictionary. After we run that backtrack, we path.pop. We can do that and then return this. No way this will work, but cannot access BT before initialization. Right, you're right. I don't think it's right, but let's see what we're missing. Output is AA. Why is it AA? I know I'm missing something, but what am I missing? Oh, you pass in the result array? Okay. And then pass in the result array. Let's see if that makes any difference. Now we're backtracking index plus one path. Oh, the pop is here. And then what the fuck? So after the backtrack, we pop. That was it. Did I understood what's going on? Of course not. Of course not. Do you get it? Why do we pop it right here? Path up pop. Because when we're after this, we have ABC. We do need to pop it first. Yeah. After we put in this into the result array, we pop. That was it. That wasn't like too hard, but just never done it before. Shit, that took me like 38 minutes, which is so bad. So, kind of want to do one more time just to see. Alright, so we know what the problem is. For each combination, return the possible letters, but also we have a limit of only 4 length of the digits. First idea, we're using backtracking. What is backtracking? After getting possible letters, backtrack, and oh, actually, you're passing in the path, which is kind of like memoization, right? You're memoizing path, so that like reduce computation. So I know the dictionary. I hate doing this. No, yes, I hate doing this. So I'm going to copy the dictionary. So we have the dictionary here. We have result equals to 0, and then const backtracking function. This backtracking function will take an index path. We're passing in digits, dictionary, and the result array. We know first right here if digits equal to empty string, I just want to return an empty array. That's it. In the backtracking, this is the best case if path.length is equals to digits.length. That means we've reached the end of possible letters. We want to push path.join the string, and then this is the backtrack. I get that now. And then if after that the possible letters goes to dictionary of the current digit. So if possible letters, so it's an if possible, if there is possible letters, we're looping that. If not, then that's it. Let I equals 0, I less than possible letters dot length plus here, and then I need to push in the path of the possible letters, the current letter, and then we're running the backtrack function into the new path that we already have, but the index move it 1. What if the index is out of bounds? What's gonna happen? There's no possible letters, then just died. Let's see. So index, and then we push in the path, the digits, the dictionary, and the result. After we edit that, we do need to pop, and then run the backtrack function on the index starting from index 0, and then pass in the current empty path, the digits, the dictionary, and the result, and then return the result. Restart push is not a function. Oh, my bad. Kind of want some oranges or eat something after this. All right, that was a tricky one because I don't know backtracking, but it seems like I get it now. Let's do one more and then combination sum. So you get the idea backtracking now, right? So let's see if I really know it. Combination sum 3. Find all valid combinations of k numbers that sum up to n such that the following conditions are true. Only numbers 1 through 9 are used. Each number is used at most once. Return a list of possible valid combinations. The list must not contain the same combination twice, and the combinations may be returned in any order. So we have a k of 3 right here and n of 7. Output is 1, 2, and 4. 1, 2, 4 is 7. There are no other valid combination. Well, all valid combinations of k numbers that sum up to n. Using 3 numbers, so you need to backtrack each one of them. Interesting. K equals to 3. The number we use is 1 through 9. So we can say like let nums equals to 1. So we're not using 0. 3, 4, 5, 6, 7, 8, 9. This. If so, because I already have some experience earlier making backtracking function algorithm, I'm just going to start with the index, and then we have the path, and then we have nums, and then we have k, and we have n, and we have result array. We will call the backtracking function first with the index 0, the path with the nums, with k, with n, and with the result, and then return res. This is what backtracking, after I'm done with the backtracking, will be there. But now, 3 meanings. Well, what is k? With k numbers. K is like the defining factor, right? So let's just use this example. K equals to k equals 3, n equals to 9. So if we use k equals 3 and equals to 9. So let's see what are the possible answer. K equals 3 and equals to 9. That thing is so loud. So can we use the same? No, we can't use the same number, so it has to be unique. So 9, 1, 2, 8. No, 1, 2, 6. And then 1, 2. Okay, I see that. This is like backtracking, right? There's no 1, 2 anymore. Can I do 1, 3, 5, right? And then 1, 3, there's no already. 1, 4, 5. And then, no, this is 10. There's no more at 1, so you backtrack 2, 3, 4. And then you go through every single combination. So you're looping through every number starting from the index of wherever. Continue that. Backtrack. Okay. Think I can try. What do I know? If path.length equals to k, that means we have found the answer. We are going to push path let sum equals to path that reduce a and b, a plus b starting from 0. I don't need that, but I don't. So I just want to say here that if we found, and if not, so let possible nums equals to nums dot slice from index to n. No, so this is gonna be index to n, and then if there's possible nums. What if there's no possible nums? I think I can just do for loop here. I don't need to do if statement. So possible nums dot length, and then plus plus, and then here let current no path dot push. Oh, we don't need to do sum. We just need to push the path because we just want the path to be an output. So let's actually make it easier. So path, and then path dot push possible nums. Oh wait, okay, here is the math where it comes in. So do I want current? I do want current. I want to keep track of the, so after current is starting from 0. Possible nums I. So 1, we're pushing it first. After that, and then current plus equals to possible nums of I, right? This is where if k minus equals 1, if k equals to 0 and current equals to n, then no, I think this is not it. I think this is this right here. So if k equals to 0 and current equals to n, we're pushing in path and return here for backtrack. And this is where I'm going to backtrack index plus 1, pass in the path, pass in the new nums is the same, k minus 1, n is the same, and result is the same. So here, 3 minus 1, 2 minus 1, 0. So I'm at 0, and I'm just gonna push result and then go out. And then here, what else do I need to think about? I need to think about if the n is the same. But I already say it right here. If not, then okay, I'll just test it. I feel like this is it. but also like I'm not a genius, you know what I mean? So expected 1, 2, 4 is nothing. We got one cases, good. This is K. One, two, three, four, five, six. What? Hmm. Let's see. So possible nums equals nums dot slice from index. Index is 0. And then we're backtracking. What? Mm, I don't get it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh lord. So K is at 3 possible nums. Nums dot slice. So it's going to be index is equals to 0 right now. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And then when index becomes 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh my god. I give up. Did I set timer here? I didn't set timer, but gotta find solution. The idea is to learn. Oh, so I think I need a remain. Remain is n. N is the number. I see. If remain equals to 0, or I can say like current, it's the same thing. And then if remain is less than equals to 0, array.length. If current is greater than the sum n, or path.length equals to k. this return to backtrack. Maybe that was it. Let me try again. Oh yeah, I forgot about the popping. So this is gonna be path pop. Something. Next start. What is the next start? Next start is in the index. So let I equals to index less than 9. And this is index less than 9 plus. I think we're close. Let's see. I think we're close. So backtrack. If k no, so we try not to use this, right? So I don't think we can use that. So if current equals to n, and if path.length equals to k, and then we use path and do that. Hmm. This is so we're at like 1 2 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3. How? So we're one at 1 2 3 index. So this is gonna be plus plus I. Let's just see. Same thing. Yeah, something is wrong here. What is wrong? So next start, we're getting 0 first, which is like the index, we get 0. And then we pass in let I equals to the index. And the backtrack, next start is I plus 1. It's not looping it. How? Backtracking I plus 1. Man, because right now it's not even going up after that. Why? For let I equals to index 0, 1. 1 plus 1 is 2, so we're at that number. I think like we keep going backtracking in the same number, is that why? So, alright, fine. Instead of current, I'm going to say remain. And remain is going to be the n. Right? Like, okay, we don't need the n. Like that. And then we just say first if the remain goes to 0 and that's that length goes to k. Okay, I don't need this possible numbers now. And then if remain less than 0, and then the backtracking this is just remain minus I minus 1. We don't need the current no more. And we don't need the n. We don't need k minus 1. We don't need k at all. What's the k is for? Yeah, we do need the k. Alright, fine. So this should be the same. So now the backtracking doesn't even go to 3. So actually path should be right here. So we can see it actually went through every single one of them. Yeah, it did. 1, 2, 3, 4, 5, 6. And then when we're calling the backtrack, if remain so it's right here, remain equals to 0. And what is path? 0, 1, 2. 0, 1, 2. Path is what? Path at length is 3 and k equals to 3. So why is this not pushing the path? So console.log, found it, and then this should go and this should return now. So 1, 2, 4. Me result.push. That result is empty string y, empty array. But why? Why do I have to do this? We have an array of 1, 2, 4. Why do we have to do this? Result is an array, and we're pushing an array inside of there. But why do we have to deconstruct? I don't get that. Does it pass? It passed. Alright, so let's do it again for one last time and then go to bed. We have a result array. Right. And then what we need to do here is the const backtracking function. Backtracking function, we need to think about index remain. We pass in path first, then remain, passing k, and then passing result. I think that's good enough. So we're calling the backtrack function from index 0, empty path. Remain is the n, k, and result, and result at the end. And then for the backtracking function, so if the remain is already at 0 and path.length equals to k. We want to, this part I don't get. Why do we need to reconstruct my array or recreate another array? Why can't we just pass in the path? But anyway, and then else if remain is less than 0 and for the path.length is equals to k, we're at that, just return. And then for let I equals to index I less than 9, I plus plus, and then here I just want to do path.push plus 1, run the backtracking function. This is I plus 1, pass in the path, pass in the remain, pass in k and pass in rest, and then path.fop. I think that's it. No, I think that's it. For remain, we need to minus submit. Okay, so that's it for today for the backtracking lesson or practice, and we do it again tomorrow. Bye.